In this video, we'll cover the topic roots of negative numbers. Like I mentioned in my previous video, the square of both 5i and negative 5i is negative 25. So, in the complex number system, negative 25 has two square roots, 5i and negative 5i. Similar to the principal square root of real numbers, we call the non-negative 5i the principal square root of negative 25. In general, we define for any positive real number b the principal square root of the number negative b as I times the square root of b. Let's look at the following example to understand this better. The square root of negative 16 times the square root of negative 9. We can't use the product rule for radicals here, because the rule doesn't work for negative numbers. So we have to express the square roots with the definition the square root of negative b equals I times the square root of b. In other words, we remove the negative sign and put an I in front of the square roots. So we can write the square root of negative 16 times the square root of negative 9 as I times the square root of 16 times I times the square root of 9. The square root of 16 is 4 and the square root of 9 is 3. So we get 4i times 3i, which is 12i squared, which is 12 times negative 1, which is simply negative 12. Again, don't make the mistake and multiply the square root of negative 16 by the square root of negative 9 to the square root of negative 16 times negative 9. Which is the square root of 144, which is then 12. This is wrong. Again, this is wrong because the product rule for radicals doesn't work for negative numbers. Let's look at two examples where we subtract and add square roots with negative numbers, respectively. The first example is the square root of negative 18 minus the square root of negative 8. We begin by using the definition and write the square root of negative 18 as I times the square root of 18. And the square root of negative 8 as I times the square root of 8. Now we can write the 18 as 2 times 9 and the 8 as 2 times 4. We couldn't split the square roots of negative 18 and negative 8, but now we have 2 times 9 and 2 times 4, which are positive numbers. So now we can split the square root of 2 times 9 and the square root of 2 times 4 into the square root of 2 times the square root of 9 and into the square root of 2 times the square root of 4. The square root of 9 is 3 and the square root of 4 is 2. Three times I times the square root of 2 minus 2 times I times the square root of 2 is 1 times I times the square root of 2, which is I times the square root of 2. And we are done with this problem. The second example is the square root of negative 27 plus the square root of negative 48. Again, we remove the negative signs under the roots. And instead of that, we put the imaginary unit I in front of the roots. Then we split the number 27 and 48 that way into 3 times 9 and 3 times 16. So we can partially take the roots. The square root of 9 is 3. And the square root of 16 is 4. Three times I times the square root of 3 plus 4 times I times the square root of 3 is 7 times I times the square root of 3, and we're done with this problem. Let's look at the next two examples. Negative 2 plus the square root of negative 3 squared. Again, we use the definition to rewrite the square root of negative 3 as I times the square root of 3. Then we use one of the three most important binomial formulas, which is a plus b squared equals a squared plus 2ab plus b squared. So a squared is negative 2 squared. 2 times a is 2 times negative 2 times b is I times the square root of 3 plus b squared is I times the square root of 3 squared. Negative 2 squared is 4. 2 times negative 2 is negative 4. We keep the I times the square root of 3. And I times the square root of 3 squared is negative 3. Because the square root and the square cancel each other out, and I squared is negative 1. 4 minus 3 is 1. And we keep the negative 4 times I times the square root of 3. So we get 1 minus 4 times I times the square root of 3, and we are done with this problem. Let's look at the next similar example. 3 minus the square root of negative 7 squared. I encourage you to pause the video and try this on your own. We rewrite the square root of negative 7 as I times the square root of 7. Then we square the 3, which is 9. And we square the I times the square root of 7, which is negative 7. Negative 2 times 3 is negative 6. And 9 minus 7 is 2. So we get 2 minus 6 times I times the square root of 7, and we're done with this problem. Let's look at the last two examples. 8 minus the square root of negative 18 over 2. The square root of negative 18 is defined as I times the square root of 18. And the square root of 18 is the square root of 2 times 9. Splitting the square root gives us the square root of 2 times the square root of 9. And the square root of 9 is 3. We can split the fraction to 8 over 2 minus 3 times I times the square root of 2 over 2. 8 divided by 2 is 4. So we get 4 minus 3 times I times the square root of 2 over 2. You can also write this as 4 minus 3 times the square root of 2 over 2 times I. What about this last example? Negative 35 plus the square root of negative 50 over 15. Square root of negative 50 is I times the square root of 50 and 50 is 2 times 25. The square root of 2 times 25 is the square root of 2 times the square root of 25. And the square root of 25 is 5. And after splitting the fraction, we get negative 35 over 15 plus 5 times I times the square root of 2 over 15. 35 divided by 5 is 7, and 15 divided by 5 is 3. 5 divided by 5 is 1, and 15 divided by 5 is 3. So we get negative 7 over 3 plus I times the square root of 2 over 3. If you want, you can also write it as negative 7 over 3 plus the square root of 2 over 3 times I. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Thanks for watching and happy learning, everyone.